All right, today we're going to dig into a story that's happening quite literally right under our feet. But it's one most of us never even think about. It's a story of these epic journeys, really violent transformations, and some incredible hidden secrets. Yep, it's the story of soil. I mean, have you ever stopped to really think about that? Why is the sand in a desert so fine and golden, but the mud next to a river is dark and rich and, well, muddy? They're both just dirt, right? Well, not exactly. The answer, it turns out, lies in the incredible, secret journey that every single one of those particles has taken.
So where does it all even begin? Well, every grain of sand, every little speck of dust, it starts its life as part of a huge, solid piece of rock. In the process of breaking that rock down, that's called weathering. It's the very first step in the life of any soil particle.
Now, there are basically two ways a rock can become soil. On one side, you've got physical weathering. You can think of this as just brute force. Ice expanding in a crack, a rock smashing down a cliff, water grinding it away. These forces just shatter the rock into smaller bits of the exact same rock. But then you've got chemical weathering, which is honestly a lot more like alchemy. This is where chemical reactions, usually involving water or weak acids, actually change the rock's minerals, creating totally new substances.
Okay, so once a particle of soil is born, it almost never stays put. It gets swept up in this amazing journey, sometimes transported across entire continents by some of the most powerful forces on Earth. And this migration, this is what gives different soils their unique personalities.
So let's meet the four main players in this story, let's call them travel agents. First, you've got water, carrying sediment in rivers and streams. Then there's wind, blowing fine dust across vast landscapes. You have ice, in the form of these massive glaciers that just grind and push everything in their way. And of course, good old gravity, just pulling loose stuff down a slope. Each one moves soil in a completely different way. And this, right here, is the key. The journey literally defines the particle. So, if a particle tumbles in a river for hundreds of miles, like you see for water, it gets all its sharp edges knocked off. It becomes smooth, rounded, polished. Water is also great at sorting particles by size. It drops the heavy ones first, which gives you a well-sorted deposit. Wind? It does something similar, but it's an even pickier sorter, carrying only the absolute finest particles for huge distances. But then, look at ice and gravity. Their journeys are short and just brutal. They don't sort anything. They just dump a whole jumbled mess of big rocks, tiny pebbles, and fine sand all together, creating this poorly sorted mix of sharp, angular, scratched-up particles.
To really see how this plays out, let's look at a couple of real-world examples. Let's explore the stories created by our most common travelers, water and wind.
First up, we've got alluvial soil. This is your classic water traveler. It's that super fertile soil you find in riverbeds, floodplains, and deltas. And because it's been carried by running water, its particles are exactly what we'd expect, right? Smooth, rounded, and nicely sorted. It's a perfect textbook example of how a long, gentle journey creates a very specific kind of soil.
Now for a soil with a completely different backstory, loess. This is a wind-transported soil. We're talking about powerful air currents picking up these unbelievably fine, silt-sized particles and just carrying them for hundreds, maybe even thousands of miles before laying them down in these thick blankets. This stuff covers huge parts of the planet, from the American Midwest all the way to China.
But here's the wild thing about loess. It has this hidden characteristic, a real plot twist in its story that makes it both surprisingly strong and incredibly dangerous.
So as the wind drops all these fine particles, they get kind of glued together by tiny amounts of natural, water-soluble cements. And when this soil is dry, that weak glue is actually enough to create a really strong, stable structure. You can build houses on it, no problem. But the moment that soil gets soaked with water, that glue just dissolves. Poof! And all of a sudden, there is absolutely nothing holding those particles together, and the entire soil structure just collapses. We're not talking about a little bit of settling either. This is the cause of catastrophic foundation failures for huge buildings and infrastructure, especially in places like China's Loess Plateau. It's a real game changer.
Okay, so what about those other two travel agents, the ones that aren't so gentle? Let's take a look at the rough and tumble soils that are created by the brute force of ice and gravity. And the contrast here is it's night and day. On one side, you have the result of that long, patient journey by water, smooth, rounded, sorted. On the other side, you have the aftermath of a short, violent trip. A glacier doesn't sort or smooth things. It grinds, it scrapes, it just dumps everything.
A rock slide doesn't care about particle size. The soils they leave behind are just a chaotic mess of sharp, jagged fragments of all different sizes.
So, we've seen soil born from rock that's been broken and carried away. But what about a more dramatic origin story? Is it possible for soil to actually be born from fire and ash?
You bet it can. Meet bentonite. This is a really unique type of clay soil that forms when volcanic ash gets chemically weathered over time. The secret to its wild behavior is a mineral called montmorillonite. It basically acts like a tiny molecular sponge, and when it gets wet, it can swell to many, many times its original size. Now, this incredible swelling makes it super useful for things like industrial sealants, but it is an absolute nightmare if you try to build a foundation on it. It causes billions of dollars in damage to homes and roads every year.
Okay, so we've heard all these fascinating stories about how soil gets around. But why does any of this actually matter in the real world? Well, it matters a whole lot because being able to read the story of the soil is totally fundamental to how we live.
You see, understanding a soil's past, knowing if it was carried by wind or water or ice, tells us pretty much everything we need to know about how it's going to behave. It tells engineers whether the ground is stable enough for a skyscraper or if it's a collapsible soil like loess. It tells farmers why that alluvial soil is so perfect for growing crops. It helps us predict which hillsides are going to be at risk for a landslide when the heavy rains come. The entire story of the soil is written right there in its texture, its shape, its composition. And learning to read that story is absolutely crucial for building a safe and sustainable world.
So the next time you walk outside, just take a second and look down. Think about where you are. Are you living on an ancient riverbed, near mountains that were carved by glaciers? Because the ground beneath your feet has an epic story to tell. So what do you think yours is?